Section 1.5, Part B. Write each function as a composition of two functions such that h of x equals f composed with g of x, or f of g of x. Well, when we're looking at these functions here, it's important that you can identify the inside and outside function. If we're looking at this composition, what part do we need to do first? We would have to evaluate the g of x first. So the g of x is what we do first. That is called our inside function. Once we evaluate g of x, now we plug into f, which is our outside function. So when we want to take a composition and split it apart into those two functions, we think of it exactly in that manner. First thing you want to think of here is, what is your inside function? Well, our inside function, or what we would do first when we plug into this, is the stuff that is in parentheses. Following order of operations, it would tell us that we have to do the 3x minus 5 before we worry about cubing anything. So our inside function, or what we do first, is that 3x minus 5. Our outside function, f of x, is what we do last. Well, what do we do last? We cube whatever value we get. So that becomes our two functions. Once you identify these, you should be easily able to compose these and show that you do indeed get this function h of x. So let's find f of g of x. That's f of 3x minus 5. So now if I put 3x minus 5 into our f function, we get 3x minus 5 cubed, which is our composition h of x. Okay, last one here. Part B. Do the same thing. Identify your inside function first. Our inside function, g of x, what would we do first if we plugged a value of x in here? We would have to evaluate x minus 2. There's our inside function. Once we get that, what's the second thing we do? Well, we would take 1 divided by whatever that thing is squared. Again, we can easily check this. Find f of g of x. That's f of x minus 2. Plug x minus 2 now into our f function, and we get 1 over x minus 2 squared. Find the domain of f of g and f composed with g. Well, let's start with our domain for f of x. Our domain for f of x, we have a possibility of a domain restriction here. The reason we have a possibility of a domain restriction is we have a variable underneath an even indexed radical, so we know that that entire expression has to be greater than or equal to 0, cannot be negative. There's our domain restriction then for f of x, which means our domain then is going to become the interval from -4 out to infinity. Find the domain for g of x. Is there a domain restriction for g of x? Nope. We do not have a variable underneath an even indexed radical. We do not have a variable in the denominator of a fraction, so our domain is simply going to be from -infinity to infinity. Finally, we need to find the domain for f composed with g. That's just the same thing as f composed with g of x, or f of g of x. Inside function first, g of x is x squared. Evaluate now, put x squared in place of x into our f function, and we get the square root of x squared plus 4. Finally here now, we want to take this function and find the domain. Well, we take the stuff underneath the radical. We know that that has to be greater than or equal to 0. Take the square root of both sides. When we go to take the square root of this, This has no real solution. Since there is no real solution here, there is no domain restriction, and our domain is from negative infinity to infinity. Okay, last two that we're going to look at are in the book, so you need to have your book open and follow along with the graphs. Like we talked about in the first half of this section, when you have expressions written in this manner, take the time to rewrite them. So f minus g of 1, remember, is just f of 1 minus g of 1. So now what we need to do here is we need to look at the graphs. F of x is given on the left there, g of x on the right. So find f of 1 first. What does f of 1 mean? It means we're plugging in 1 for x. When we put 1 in for x in that graph on the left, what value of y do we get out? 2. When we plug in 1 to the g function, what value of y do you get out? 3. And 2 minus 3 is negative 1. Second part, remember, is f of 4 times g of 4. To find f of 4 first, plug 4 in for x, we get out 4 for y. And our g function on the right, plug in 4, we get out a y value of 0, and 4 times 0 is just 0. F composed with g of 1 is f of g of 1. Do your inside function first. G of 1. Plug 1 into the g function. What do we get out for y? We get out 3. So now we're plugging 3 into the f function. Plug 3 into the f function, and we get out 2. The last one, g composed with f of 3, remember, is g of f of 3. Finding f of 3 first. Plug 3 in for x in our f function. We get out 2. Plug 2 now in for x in the g function, and you get out 2.